Let's draw our fluid inside our user interface. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episode, we draw the textures, we draw our progress bar. We tried some arbitrary numbers that showed how we can reduce or add numbers so that our progress bar would be animated properly. And we have this to do for drawing a test of our water inside our container. However, I just did code the numbers and the variables, and when I stopped the video, I noticed that I'm doing it in draw foreground. This is not the proper place to do it. If you understand how things work, draw background will draw a solid image and will be called only once when you open the GUI. The draw foreground will draw solid images again, and it will happen every frame, I think, but it's not proper for drawing something that is dynamic. So if you want to do something that is dynamic, like calculating values and then drawing things based on those calculations, or if you want to draw tooltips, you need to do them in the render call. So I will paste it here in the render call. Now that I have the fluid height from the previous video, it's time to get the texture of the water. However, if you know how fluid is actually being registered in Minecraft, you would know that we have this solid fluid and flowing fluid textures that are grayscale. And Minecraft will register fluids using that grayscale texture and add color on top of it as a tint to draw water. Knowing this, it means that we can't just call a texture from file on hard drive and then get done with it. Also, in this simple scenario, we are using water dedicatedly, but if it was a fluid tank, we don't know what type of fluid is in there to just call a texture and call it a day. So we need to somehow get the related texture for a fluid from the game itself. And thankfully, there are tools for that. So we say fluid render handler, and you see that it's from the Fabric API, and we call it fluid render handler equals to fluid render handler dot instance. Having instance like this means that it's just a singleton dot get for the fluid that we have. Sorry, it's not fluid render handler, it has a registry. That one has an instance as a singleton. Okay, now that we have it, we can say if the fluid render handler does not equal null and our amount is actually greater than 0. Of course, it says that it's irrelevant because it's a solid number right now, but take note, things will happen and change when we are dealing with a real fluid container. It will not be a solid number anymore. So this warning will be done and gone. Just keep it there. Now we want to get the block pause and the fluid state and work. So we say the block pause, we call it pause equals to this dot position supplier dot get. Now let me see. I think I changed the name in the constructor, or I need to, yeah, I need to keep it because right now we have the payload somewhere, I think. Oh no, wait. Now to get the block pause, we say this dot handler dot get block entity, and we will come back to this, and then we can say dot get pause. Okay. Now get block entity is a method that we will have on our screen handler that returns the block entity. Don't worry about that. But having the block pause right now, we can easily get the word and the fluid state. So we say fluid state and we call it fluid state equals to fluid dot get default state. Now this means that if we were using a flowing fluid, we will get a flowing state. If we are solid, then we get the solid state. After that, we say world equals to. Now here is something that we won't use outside of the user interfaces. We directly call Minecraft client, and from there we get dot get instance, and from instance we get the word. Now this will work on the user interfaces because on the user interface we are sure that we are on the client side. It's the job of the client side to draw the GUI, and because of that we can call the Minecraft client. Anywhere else in any other logic related to the game, be very careful. Only call that Minecraft client.getInstance.word when you are 100% sure that you are on the client side. Okay, now that we have all of the information we need, we can retrieve the sprite. The sprite is a texture that is tiled by different things. For example, you have water, you have lava, you have blocks. All of them are sitting inside each other and stitched into a very big texture, and that is called the sprite. Normally, if you are familiar with game development, that is not a surprise. So we want to get the still texture, or if you want to, you can use the animated texture. However, because this is a solid container and normally fluids in the containers will be solid, so will be still, so we get the still texture. We get the fluid render handler, and then we get the fluid sprites for the world on the position that we have with the fluid state that we have, and this will return an array. We will retrieve the index 0. That's the still animation. If we use index 1, that is the flowing animation. Now that we have this sprite, we can continue on with say int tint color equals to fluid render handler dot get fluid color, again for the world position and fluid state. Because as I said, the color for the water and normally any other fluid that you will work is grayscale, and you use tint color on top of that. Now we need to convert this integer into red, green, and blue components that are floats. So we say float red equals to tint color. Now what I'm doing here is actually called bit shifting operation. If you don't know what is a bit shift operation, you can just look around the Google. Basically, we are moving the zeros and ones inside a 64-bit array that is an integer toward the right or toward the left to just get a section of that, and then divide it by 255 gives us a float number between 0 and 1. If you don't want to dive into that knowledge base, that's okay. Just keep this and you can simply use this as any utility class, and I will convert into a utility class. However, instead of this 255 integer, I will use 0xff. That's the same thing, but you know what? When it comes to bit shift operation, it's better to have these sort of values. Now that we have that, we can use a screen utils helper class that I have and call render tiled sprite. Don't worry, we will take a look at that code in few minutes, and you will see how the vanilla way of drawing it is actually handled. So we go with context, then we want the render layer. So render layer colon get GUI textured, and then we have the still sprite, so still texture. We want to draw it at the x, y. So let's start with the x. We don't want this one. Now the x will be here on top. 8329. So 8329. Then we want the width and the height. Now the width is fixed and the width is this guy, 16, but the height is actually calculated based on the fluid height that we want. And I am making a wrong thing here. I will tell you what in a few seconds. Then we want the color. So I hope that I have the color helper. Yes, and this color helper is mine, isn't it? I'm taking a look at my notes. No, actually it comes from Minecraft. Okay, nice. So it's Minecraft's color helper, and we say dot from floats. Now I assume it's mine, not Minecraft's. Okay, let me see. Where's that color helper import? Yeah, remove that one. And it shouldn't be that. It's net Minecraft utilmat. I imported the wrong color helper. Okay. Now this is the alpha, means the solidness and transparency. Then we have red, green, and blue. Okay. We still have problem. The code will not run because there is a problem here. Let me just break this one down and take a look at this render titled sprite. Now, this is how you will draw the proper fluid inside anything. And this is why I have it as a utility helper class. If you want to, you can just pause the video or you can go into the repository and take a look at the code. If you want the repository, the link is in Discord description and the link for the Discord is in the description of this video. What we have is the width and height of the sprite. Then we have the floor of the width with the sprite width. We want to see how many tiles of the 16 by 16 we have and the reminder values of that division. Then we want to get the atlas ID of this sprite in the game. We want to get the menu, min-v, and then we go with those tile counts and, get the sprites and draw the quads for the image using the context. So we are drawing 16 by 16 textures, and we do it for the y count, then for the reminder, and then we go for the x reminders and y reminders if the x reminder is actually actually greater than 0. Basically, we are getting 16 by 16 textures and the pixels, and we will draw that. Okay, you can have it if you want to in your own code as a vanilla code. You saw that we are just calling context.drawQuad, but the mathematics are just simple. You can follow it on the code. Now, finally, we need this get block entity. Now, going back into handler, we are sending in the block entity. However, we don't have that block entity cached anyway. So to cache this block entity, we say that, you know what, it's a block entity and we call it block entity. Here we say this dot block entity calls to the block entity, and finally at the very end we have public that returns a block entity and we call it get block entity. All we are doing, we are returning this dot, actually I can just say block entity, it will work. So the problem here is solved. Of course, I can't use hot swap now because I introduced a new property in a class that was not there. Let me show you that it will not work. So I will do the hot swap and it says it failed because I added something here. So now I need to rerun the game. Now, as we are waiting for the game to come up, I will tell you that I have a terrible problem here. The problem is that I'm drawing from this pixel, and we are gonna see something that is weird in few seconds because the placement is not correct. I want to show it first, and then when you saw the result, we will see how the correct math will work. Keep in mind, it is happening for fluid right now, but when we go into the energy bar, we will have the same problem. Okay, so let's go into the game and let's try to open the GUI. However, keep in mind, what I want to see right now is that I should not have any null point exception. I may not see the fluid, I may see the fluid in wrong place, whatever. And as you see, I'm not seeing the fluid. However, in the console, I don't get any errors. That's a good thing. And now I can pin this to the monitor and we can continue. The reason I'm not seeing the height right now is that I should tweak this height value, this y value actually. So the y is 29. I should add the height. What is the height? The height is the height of the container, so it should be 62, as you see. So I will say plus 62 minus the fluid height that we calculated. If I do a hot swap now, it should show up. We are drawing the fluid way ahead. So our x is wrong, apparently. Let's see the x value. So the x value for this guy is 83, and I assigned 83 here. However, it looks like it's not the proper position. So I need to say this dot x plus 83. And here for the y, I need to say this dot y plus those things. Okay? And now if I do the hot swap, it's in the proper place. This is 1/5 of the whole thing. And you see that it's solid. It's not being animated. Now, if I use this as 1 and hot swap, now you see that it's vertically stretched. But again, it's not getting animated. So it's easier to have the 0 and get the solid water, and that's okay. Now, if I increase the number of buckets that I have, let's say I have 4. Now we have equivalent of 4 buckets. 8, it's 8 buckets. 9 buckets. And finally, if I convert it to be 10, it should be a full tank now. And it is. So let's go with 3. What if I want to draw lava? Well, guess what? Just change that to lava. And you have lava in the container, okay? And of course, that red dot is now in a very bad place. But let's go with 5. You see that it's there. However, the marker is not being drawn here. I think it was the case with water too. So the foreground is not actually being drawn on top of the fluid. So I will get that line that is drawing the markers, moving it to render. It doesn't matter. It should work. And now you see that it's in wrong place because now we need to say this dot x plus and this dot y plus. This is the huge difference between a render and draw foreground. Draw foreground by default knows that it's starting from the corner of the texture, but draw render is it starts from the top left of the screen. So you need to add this dot x and this dot y, and let's do the hot swap. And now you see that our markers are being drawn on top of our fluid. So let's convert it back to water and let's rerun again. Bingo. Now we have water inside the container that is marked properly. Now, this may look like, okay, we have done it and we have it, but take note, I have few other blocks that will actually have fluid containers in them. One of them will be fluid tanks. The other one will be smelter that will have lava in it. And yes, you can copy paste this code over and over and over into many different classes and use them. Or alternatively, you can draw something else in another way and utilize it more than once. We can have a widget, a custom widget that will draw fluids for us. Also, we can have a custom widget that will draw energy bars for us. We can have a custom widget that will draw progress bar for us. Long story short, it's up to you. You can copy paste this code over and over and over and just change the type of the fluid. And yes, we will read these from the containers inside the game later, but you can have your own custom widgets and show them properly with just few lines of code. And instead of all of this, you will have something like this, After this render, you can have something like add drawable, and here we say new fluid widget. By the way, we don't have this class, it's just a mockup, and then we will have a builder, and inside the builder we will say this.handler dot get block entity, I don't know, maybe get fluid tank, so we are sending in the fluid tank directly. After that we say we close the builder, but we will call methods on the builder, for example bound, because we are going to give a boundary, and we say this.x plus the value that we have here, what was it, 83, yes, comma, this.y plus the original height was what, 29, okay, have it there. And then the width was originally 16 and the height was 62, okay. So after the bound we will say dot position supplier, because we are using that supplier, and we add a lambda. We say that, hey, it's this dot handler dot get block entity dot get pause. So that's our position supplier. And then finally we call the build and get done with it. So it will be a widget that we can have, and just by doing it, all this mumbo jumbo will happen inside that widget and it will render itself. And even after building, it will support something like a tooltip that shows the amount of the fluid. Right now we didn't add that tooltip because honestly it's not meaningful to do it right now, but if you so want to, you can have a draw tooltip. So here we will say, actually at the end we will say draw tooltip as a method, and finally here we call the draw tooltip. So we say maybe private, maybe protected, who cares, void draw tooltip, and here we need a draw context. We call it context, then int mouse x, int mouse y, and finally we need something else, and this is the long amount and long capacity, okay. However, remember that right now we are not checking the boundaries, so we need to check for the boundary using int x, int y, int width, and int height. Okay, here we say if not mouse helper dot is mouse over, okay, and we want this overload, so is mouse over with the mouse x, with the mouse y, with the x, y, with height, we just return. Now what do I do in this mouse over? It's really not big deal. We can just take a look. We are just checking the boundary of the mouse. That mouse should be inside x plus offset and the x plus offset plus width, the y plus offset and y plus offset plus the height. And for the offset, I'm using the 0 as x and y. So now that we made sure that we are in the boundary of this tank, we want to draw the tooltip. So we say context dot draw tooltip, and here we want the text renderer. After that, the text. Now the text is something that we will define in few seconds. Then we want the mouse x and mouse y. Now for the text, we say a list of text, and the text comes from net Minecraft text. We call it text equals to list.of. Here we say text dot. We can do translation, but I will go with literal. Let me just take the whole thing because it's just something that we will work later. And this is the amount, this is the capacity. And let me do the full screen so that you can see what's going on. All I'm doing here is that I'm dividing the amount to a bucket and then multiply it by 1000. This converts it from the units of fabric into a more universal unit that we know into the game called millibucket. And don't worry, we will talk about fluids in depth in another video. Just know that in fabric a bucket is 81,000, but in Forge and NeoForge a bucket is 1000 units, and each one from the 1000 unit we'll call millibucket. So in fabric we don't have millibuckets. This is the math to convert that 81,000 unit to 1000 unit, both for the amount and for the capacity. And then of course this will be a float, so we need to convert it to integer because we want to go from 1 to 1000. And then we add in text millibucket. Of course it's single text, but here we need a list of text, so we call it texts, and that's it. So if I run it right now, I have an error. I need to fix that. We need to send in the context, then we need to send in the x, so this.x and this.y, then the width, we don't have it yet, height and mouse x, mouse y, the amount and the capacity. Now for the x, it's this.x plus 83. The y is this part, and then the width is 16 and the height is actually 62. Now I can run the game, but if I do the hot swap, it will fail because we added our own method to the whole thing, and you see that it says we failed. So now we need to rerun the game. Okay, I forgot that I have this mockup on the top. I will comment it, rerun the debug, and I will come back when the game is ready. In the meantime, if you want to, you can pause the video and take a look at this math and rewrite it somewhere. I will have a helper method that will handle it in future, but if you want to, you can just do the math yourself. This is in front of the camera right now. By the way, do I need to remind you that the whole project is on GitHub repository, and the link for GitHub repository is already presented in Discord. You can read the description of the video, and the link of the Discord channel is in the description. Please join the Discord channel and please tell everyone about this YouTube channel and help me grow the community around the channel. Let's click the mouse, and you see that I did something wrong, and the Y offset is wrong, but the X offset is correct. So when I move my mouse around, I see this tooltip, but as I said, the Y offset is wrong. Let's go for the Y. I think we shouldn't add it here. Just do the hot swap now, and yes, it fixed the problem. So when my mouse moves into the tank, you can see that number here. Of course, we don't have any 1000 separators right now. If you want to, you can play with string formatting for that, but that's up to you right now. Anyway, we converted that 5 multiplied 81,000 into 5,000, and I don't know, 810,000 into 10,000. Now remember, we are not doing it in the concept of the tank itself. We will talk about that in future, and we will see what's wrong with that approach in future. However, right now we have a functional user interface that we can use to draw the GUI of everything. However, we don't have any slots, not a player slot, not any slots for the inputs or the outputs. Also, take note, I have this gem cleaner inside my inventory. Let's do something crazy. I will get this thing and I will fill my inventory with some things, okay? And I will open the GUI. I don't see them because we are not presenting the player's inventory into the game. For few episodes in future, we are done with the screen renderer itself. However, the job of adding the player's inventory, player's hotbar, and other slots for inputs and outputs into the GUI is the responsibility of the handler, not the renderer. The job of renderer is just this, drawing things. So in the next video, we have to come back and work with a screen handler to make our player inventory presentable, to make other things happen one after another as we progress forward. Right now, I need to put some to-dos here. First, I need to make sure that we are handling the progress, and we are handling the energy, and we are handling the fluid. These three are the things that we need to replace. Of course, drawing the fluid markers are solid thing. Tooltip, again, is something that we can handle properly by the fluid tooltip, okay? But Beyond that, we are done with our screen renderer right now. Now I can get rid of this constant here. And in the next video, we come back and work on our screen handler. The very first thing we want to add here is that we want to make sure that we can see the player's inventory into the game. So in the next video, we will come back and talk about that. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.